Hi Year 12, Mr. Vinord here. Today we're going to look through solutions and how to calculate their concentration. So first of all, before we go too far, it's important to define what a solution is in a chemistry context. So a solution is when I take some solid, which we would call the solute, and I dissolve it in a liquid, which we would call the solvent. And when I have a solute and it's dissolved in a solvent, that gives me a solution. So a solute could be a pure substance, a solvent could be a pure substance, but a solution can never be a pure substance. A pure substance by definition is a substance made up of only one type of particle. So a solution, if it involves solute and solvent, two different types of particles, can never be a pure substance. So that's what a solution is. And when we talk about concentration, we're talking about how much solute is there per mil of solvent or per litre, per unit volume. Because we could have a really pale shade of red solution if there's just a little bit of solute, or we could have a really dark red solution if there was lots and lots of solute dissolved in a little bit of solvent. So the concentration can change, the number of particles per mil or per litre. So we need a way to calculate the concentration in some sort of standard way of writing it. So let's have a look through how we do that. So first of all, we're going to look at this example here. If I had 5 grams of sodium chloride or table salt, and I put that into 200 mils of water, how would I express its concentration? That is the question. You can do this experiment at home. Weigh out 5 grams of salt, put it into 200 mils of water, and you can have a taste of that solution that we're talking about. So there are two different ways we can express concentration. We can express it in grams per litre, or we can express it in moles per litre. There are other ways of doing it in terms of percentages, but we'll just stick with these two for today. So first of all, let's have a look through how to calculate this in terms of grams per litre. So to calculate concentration in grams per litre, I simply take the mass of the solute and divide it by the volume of the solvent. So in terms of our question that we're talking about, we said we had 5 grams of sodium chloride and we were going to dissolve it in 200 mils of solution. Now the standard unit for volume is always litres. So the first thing I had to do was convert my 200 mils into 0.2 litres. And the way you convert mils into litres is by dividing by 1,000. So my 200 mils divided by 1,000 becomes 0.2 litres. So if I take my 5 grams and divide it by 0.2 litres, I get 25 grams per litre. So that's the concentration of that initial solution in grams per litre. The second way we can calculate concentration is in moles per litre, and this tends to be the more standard way of calculating concentration in a chemistry context. So first of all, if I want to work out the concentration of moles per litre, I need to know how many moles of sodium chloride there were in my 5 grams of sodium chloride. So to work out number of moles from mass, I need to divide by the molar mass. The molar mass of sodium chloride is sodium plus chlorine from the periodic table. That gives me 58.5 grams per mole. So my 5 grams of sodium chloride divided by the molar mass, which is 58.5, gives me 0.0855 mole of sodium chloride. So that's the first step, work out the number of moles. Now I can express it as a concentration in terms of moles per litre by dividing my number of moles by the volume. So my number of moles I've just calculated was 0.0855. The volume is still the same as from the other example, 0.2 litres or 200 mils. So if I divide my number of moles, 0.0855 by 0.2, I get 0.427 moles per litre. So these two concentrations, even though they are quite drastically different numbers, represent the same solution and are talking about the same number of particles per mil. This is talking about it in a mass context, this is talking about it in a number of moles context. So that's the two ways of calculating the concentration of a solution. So just a few reference points here. Concentration in moles per litre, which is the main form of concentration that we're going to talk about. Concentration equals number of moles, or the amount, divided by the volume. That's the equation that we are going to use. So that's for concentration in moles per litre. We take the number of moles, or the amount, in moles, and the volume. The volume must always be in litres. The symbols that go with those three things: concentration is a lowercase c, amount or number of moles is still a lowercase n, that's the same as before, and volume is a capital V. So concentration equals number of moles divided by volume. And that can be represented by this triangle, which a lot of you are familiar with. Concentration equals number of moles divided by volume. Number of moles, if I want to work that one out, equals concentration times volume. Or volume, if I want to work that one out, equals number of moles divided by concentration. So let's work through a couple of questions. This question is taken from your textbook. If I have 0.1 mole of sodium hydroxide in 250 mils and I dilute that to 1 litre. So when I dilute something, it means I'm adding more of the solvent. In most cases, or in all the cases we're going to look at, that solvent is always going to be water. So I've taken 250 mils of my solution, it had 0.1 mole in it, and I've diluted that up to a litre. That means I've added 750 mils more. Calculate the concentration before and after dilution. Let's see if we can work this one through. So before dilution, I need to work out my concentration in moles per litre. I have the number of moles and I have the volume, so let's work it out. Before, concentration equals number of moles divided by volume. Same equation as before. My number of moles is 0.1 mole. My volume needs to be in litres, so 250 mils turned into litres, we divide by 1,000 to get 0.25 litres. That gives me a concentration of 0.4 mole per litre. That's the initial concentration before the dilution has taken place. Now I add my 750 mils more water in, and I need to work out the concentration after I've diluted it. This number should be a smaller number because I have the same number of particles of sodium hydroxide, but now spread out in more solution. So let's have a look. I do the exact same thing. Concentration equals number of moles divided by volume. The number of moles is still 0.1. The volume this time is now a litre. That's my final volume, the diluted volume. So I'm going to dilute it by 1, or divide it by 1. That gives me a final concentration of 0.1 mole per litre. So my initial solution was 0.4 moles per litre. When I added the extra 750 mils, it diluted my solution and lowered the concentration to 0.1 mole per litre. So if you were given an initial concentration and you're told that it's diluted, you can do a simple calculation to work out the final concentration. And it looks like this. From my initial concentration, which I worked out to be 0.4, I diluted it from 250 mils up to a litre. So if I take my initial concentration and multiply it by my initial volume of 250 mils, divided by my final volume of 1,000 mils, that's called a dilution factor. So if I take my initial concentration and times it by this dilution factor, it will give me my final concentration, which is 0.1 mole per litre. So that's a little shortcut if you're given the initial concentration and the initial and final volume, and you're asked to find the final volume. That's not what we were asked to do in our previous question, but it could be for some of the ones you might come across. I hope you found this helpful. All the best.